who is going to be brave to make a construction on Desmos? Thank you, Nathan.
Okay, thanks to Ben for helping with this. X squared plus y squared equals 1. So we get a nice circle. Let's just zoom in a little bit. But now I'm going to make a point that is... We need to define A first.
No, it'll let you do it.
Oh, will it? Cos A sine of A. So there's that one. Oh, can we add a slider now? Oh no, there it is, cool. Okay, and then we make some functions.
I got the slider.
Yeah, I got the slider, yeah. Y equals sine of A, and then we go X equals cos of A, like that. And then we can change this to go from 0 to like 8 times pi, like that.
So if you just type pi, it will reduce the
Yeah. Started at 0. Well, that's really fast. But yeah, sine and cosine visualized. And I haven't quite figured out how to make like the sine and cosine waves come off it and shoot off down the axes yet.
Yeah,
but
so we want to stop the purple function when it gets to the circle, and then after that, draw just sine A.
yeah,
What was that?
So we want to stop the purple line once it gets to the circle.
Which circle?
so we want it to go
Once it
from
gets to the
here
red line,
and like
and then
go
after
off.
the red line, we want to just draw sine A.
Give us a week and we'll get back to you.
Well, you can
But yeah.
do like x equals sine A, where A is greater than x.
Yeah, that's something I came across too. It's like when you define A separately, then you can animate it. But if you don't define A, then you can define boundaries for it. You can't do both.
All right, who's going to go next?
Yeah, well, shall I start a new one?
Yes, we'll start a new one.
Okay. Ready? Follow.
So this is, in my opinion, a negative of Desmos, something that I don't like about it because it doesn't work. But if you want, one thing that you can do is you can define parametric functions. C. So this works sort of like an if statement for those who do much programming, where we can create these values for C from C goes to 1 to, say, 3. And then we can define functions of H of C minus 1 multiplied by T. And then we put in one function of T, so for example, T squared. And then you can do, and then you can define H is equal to the set X is equal to from 0 to 1. So get rid of that one.
I'm confuzzled.
I am puzzled too.
Yeah, am I getting this notation right?
No.
Okay, I'm just going to bring.
Desmos doesn't like it. What are you trying to achieve?
So I'm just going to bring
H
up
is,
the.
H is that H times C minus 1?
Yes.
And this H is supposed to be the numbers
Sorry.
0 and 1?
Sorry, there it is. H of X is a function. There we go. And now if we put some nice bounds on this, we can go from -100 to 100. And if we select the entire thing, Control C, because right-click copy doesn't work, which is another bad thing. And then we can define a second function, so e to the t, where t is between -100 and 100. Then that means, and then if we do from c minus 2, that means h of c minus 2 is equal to undefined, because c is equal to 1, c minus 2 is equal to negative 1.
Your h function is equal to 1 when x is 0 and undefined elsewhere.
Yes.
Right.
It's equal, h of it should also be equal to 1 if x equals 1, I think.
Can you write h of 1 in a box further down?
Yes.
So is h an indicator function?
Yes, it's an indicator function.
h of 1 is undefined.
Oh, okay. So I guess it's just if it's equal to 0.
So at the moment, there's the curly brackets thing. This is a condition and then a colon. Sorry, this is a condition and then a colon, and then what the answer is when you have that condition, and you can put a comma and then do as many of them as you want. Yeah.
Right.
Oh, so if the input is 0, the output is 1.
And that's
Okay.
all it does at the moment.
So if the input is 1, then the output is 3, say.
Yeah.
But that caused everything to go wrong. So when c equals 1, the function is x squared. When c equals 2, the function is e to the power of t. And this is another problem with Desmos.
Don't see problems yet, but that's okay.
Alright. Floor of t for negative 100 to 100. The floor function did not work when you express it in this form in the Math Learning Center computers.
Okay.
What might happen is that it does work correctly and I'll look stupid, but
You need a c minus 3.
I'll see minus 3, thanks. Okay, it does work. It's just yeah, okay. It could have been something to do with the Math Learning Center computers.
Which, as we all understand, are not very good.
Yeah. So the point is that we can define this conditional function h, which lets us go between different types of graphs. So it's it can work like an if statement. We could also use them to cycle between log axes and regular axes.
That's fun.
And we could do other things. I can't think of anything else.
So you could also have... No, that's wrong, doesn't it?
Okay, what were you going to say?
I was just going to say, you could have done h and put a number inside it, but that's not going to work because you need to be undefined when it's something else.
If it was equal to 0, otherwise, that might have been...
Right, one more person, Emily. We might be able to do 2 more.
Okay. Mine is slightly longer, but it's fun. So I like just putting in random numbers to things and seeing what happens. So I think you've also realized that I'm kind of silly.
X 5 plus y to 1.2 is 0.8.
Yes, so I made this because I drew random things and it was fun. Talk amongst yourselves.
So it's got negative number to the pi doesn't exist, which makes sense
Yes.
because negative number to irrational power isn't real.
Yes. This is how, yeah, that's what I was thinking about.
Sorry, there's many functions.
So you need to get darkness.
Oh my God.
Don't spoil my surprise. It gets better.
This, oh, it's so good.
You know how you're in front of the class and you just forget how to use a keyboard?
Happens to me all the time. Yeah.
So I like how you're showing us how this domain restriction works.
You will see a better example of that in a moment.
Oh my God, it's penguin.
Oh, you've made them tangent. Well, at least it looks like they are.
So you can then use the curly brackets to specify
Domain.
yes, but I don't know how to do the greater than, oh, there we go. different on my phone. 5.4. So what I did to start with was that I drew a line about there, and then I looked for this intersection point, and then I restricted the domain in that way because I wasn't going to work it out just by looking at it.
So you notice that curly brackets thing is the same thing we had before. If you don't specify what is, that's a condition. If you don't specify what it's equal to under that condition, then it will just be 1 under that condition and 0 otherwise, and undefined otherwise. So essentially we've got 5.3 times something that's 1 when y is equal to that, and something that's undefined when y isn't equal to that.
Ooh. No, that's okay. Sorry, I'm...
Why don't you draw the line and find the thing, like you did? Can you
No,
show
I'm
us
just...
that bit?
Oh, yes.
Can you show us that process?
So I've got this line here, so it's minus 5.736, and I know that I want it to end where this one is, which is minus 8. So I'm going to put in my minus 8, y minus 5.736.
If you did like curly bracket x between 1 and 2, and then curly bracket.
And then it gets better because we can go x plus 3.5, whoops, squared, minus 3.5, and then we've got too much, so we are going to then specify that, I can't see this, minus 4.8, y, whatever that number is, and I can't, 2.2.
No.
Oh, really?
I think you might need to put a y equals at the front because you referred to y and it hasn't got a y in the expression.
Yes.
Or just equals y.
Worked on my phone. Oh no, because that's a y equals. Okay. No, it's not. This is an x equals. Okay, and then... Wait, where'd my a go?
Oh, I know what you're going to do. Okay.
And then a is equal
Just click on the slider
to... Oh yeah.
and ignore that a is equal to that you just made.
Yeah, just play.
So between minus, whoops. So a is between minus 1 and 1.
You don't have to go a step if you don't want.
Okay. Oops. Okay, let's speed it up. So he flaps the wrong way, but it's close enough. Yeah.
Well done. Well,
I'm quite proud of it.
we only have about a minute until the recording runs out, and then some more people are going to come, and I'm going to take them on a tour. So we might just stop there. Thank you, everyone. That was very excellent. It's fun to learn things together and to play with stuff. So feel free to play with Desmos in front of students if you think it might help. Yeah, I think that it's good to know these tools because sometimes you'll see the students using it themselves as well, and so you can at least know what they're doing when they're using it.
Move the slider up to one.
There we go.